Hello friends. Welcome to T Academy. In this video, let's continue the TNEB electronics paper solutions. The question number we'll discuss 1 or 2. In my previous video, we discussed up to question number 101, right? So in this solutions, we'll discuss the control systems and the communication engineering paper solutions here. So start the question here. The question number is 102. If there are n routes from the source to the destination, total end-to-end delay in the sending packet PL, okay, packet P, L is the number of bits in the packet and R is the transmission line rate. So the answer will be equal to, so option 2 will be N into L by R. So option 2 is the right answer for this question here. Okay, and the next one, the question number 105. For a 100 Mbps Ethernet link, if the length of the packet is 32 bits, the transmission delay is in. So actually the question here it is 10 milliseconds they given. Actually it should be in microseconds. That's the reason why the answer will not evaluated here, and they give equal marks. So our option will be 10 bits per 10 Mbps. Let me erase here. 32 bits. Okay, 10 Mbps means it's going to be 3.2 mega becomes microseconds here. That will be the answer. So answer is 3.2 microseconds. Actually it's not a millisecond, right? Next, question number 103 we'll discuss. The best mode of connection between the devices which needed to send or receive the large amount of data over the short distance is, it is serial port. It's not serial port, it's a parallel port. Parallel port is the answer. So serial port will be slow and time taking process. Next one, let a signal x of t is finite and 0 outside the interval ta tb, where ta and tb are finite. The region of convergence of the signals bilateral Laplace transform is. So its options are a parallel strip containing j omega axis, a half place containing j omega axis, the entire S plane, and a parallel strip not containing j omega axis. So it is the entire S plane here. Next one, if the channel band limited to 6 kHz and the signal noise to ratio is 16, what will be the capacity of the channel here? Okay, the capacity of the channel C is equal to, so basic is B log base 2 to the power of 1 plus signal to noise ratio here. Okay, so B is nothing but 6 kHz. We will write it as 6000 into log base 2, so 1 plus 16. Okay, so it will be 17. If you solve this, then you will get it as 24.74 kbps is the answer. So answer is 2 is the right answer here. Next one, let a signal x of t is equal to 3 cos pi 3 cos at 10 pi t and cos 30 pi t is sampled at a rate 20 samples per second and reconstructed using an ideal low pass filter with a cutoff frequency of 20 Hz. The frequency or frequencies present in the reconstructed signal are. So here we are using a low pass filter of cutoff frequency of 20 Hz. So just see the answer. If you see the answer, all our options are having a less than 20 Hz only. Okay, so first to find the value of f1 and f2. Okay, so let me do here. So here first we'll take fs, sampling frequency is what, 20 Hz. Okay, so from this I can write the first frequency f1 is nothing but 10 pi t. Okay, omega is nothing but 2 pi f. If you solve this, f is going to be 2 pi f, right? And here also f2 will be what, 15. Okay, so these are the two options available between the 2 kHz, right? So 5 and 15, so both are sampled. Okay, so answer will be 5 Hz and 15 Hz respectively. So there will be a long process for solving this paper question. We need to find the sampling rate. Okay, we need to, but I'm just giving a short form here. Okay, this will be not exact answer, but it will be a short form for the answer, right? Next one, the transfer function of FIR filters will have. The transfer function of FIR filters will have poles and zeros, only poles, only zeros, only constants. So answer will be FIR filter will have only zeros here. Next question. If the region of convergence of Z transform of x of n plus y of n is in the range of 0.3 and 0.6, then the range of region of convergence of Z transform is x of s minus y of n. So region of convergence will not change, okay, if you do perform both the operations. So answer will be 0.3 less than Z less than 0.6 here. Let's move to the next question here. If x of n is equal to 1 by 3 whole power n minus 1 by 2 power n into u of n, then the region of convergence of the Z transform in the Z plane is. So it is going to be half less than Z less than 3. Option 2 will be the right answer here. Next question number 112. How many complex additions are required to be performed in the linear filtering of the sequence using FFT algorithm? So option is 2n log base 2n. Next question number 110. The impulse response h of t of an continuous time linear time invariant system is described by h of t is equal to e power at into u of t plus e power bt into u of minus t, where u of t denotes the unit step function and ab are the real constants. This system is stable if, okay, a system is stable if a is negative and b is a positive. So option 3 will be the right answer. Next one. A n-point discrete time sequence is passed through a n-point DFT calculator and it is used. It is output. Its output is passed through another n-point DFT calculator. The output of the second calculator is a n-point discrete time sequence is passed through a n-point DFT calculator and its output is passed through another n-point DFT calculator. The output of the second calculator is, okay. The answer for this question is, that is the time reversed version of the input sequence, okay. So let's come to the question number 114 here, right? The 114. A Blackman window can eliminate the ripple in the FIR filter. The trade-off is, options are layer transmission bandwidth, smaller transmission bandwidth, non-linear phase response instability. So answer will be larger transition bandwidth. The next question here. Consider the unity feedback system with a local loop transfer function they given here. G of s is equal to k divided by s minus 1 into s square plus 4s plus 7 here. Okay, so this is a root locus diagram. We need to draw a root locus exists on the real axis in between. So first of all, take the poles here. The poles are locating at s is equal to 1 pole. That's on the right half of the s plane. And s square plus 4s plus 7. So if you solve this, we'll get the point as the two poles will get it as, so they are at s is equal to minus 2 plus or minus j root 3. That means if you are drawing the root locus diagram like this, so one pole is lying on the outside of this s plane when s is equal to 1 here, and the two poles are lying one on the positive, that is a, let me take minus 2 here. So here plus j root 3 and here we have minus j root 3, right? Now, so where the root locus will lie here. So on the real axis, to the right side of any, okay, any section, you can consider anywhere, okay. Suppose you will consider here, I will consider here, okay, 2 points, okay. If the sum of the total number of poles and zeros are odd, okay, total number of poles and zeros are odd, the root locus diagram will exist in the section. The root locus diagram will exist in the section. See here. So here I'll talk. Here if I take here, okay, it's a right side. It's a right side. The odd number of poles and zeros should be there. So here we have only one. So one is nothing but odd. So one is nothing but odd here. Okay. So the existing point will be s is equal to 1 here. Now if you see here at this point, total number of zeros and poles here. So here we have 1, here we have 2, and here we have 3. Okay, so existing point will be here. That means it is going to be somewhere else here. S is equal to minus infinity. So answer will be s is equal to 1 and s is equal to minus infinity for this question here. Next one, we'll talk about the 115 question here. A DSP involves convolutes each discrete samples with a coefficients minus 0.25, minus 0.251, minus 0.25 and minus 0.25. This must be a. So this must be a high pass filter. So option is 2 will be the right answer. Next one. The gain margin and phase margin of a feedback system is with g of s into h of s is equal to 4 divided by s plus 10 cube r. Okay, so we cannot find the phase margin and gain margin with the open loop transfer function here with this question. So this question will not have answer. Next question here, right. The unit step response of a system is 1 minus e power minus t into 1 plus t into u of t the system represents. So first of all, check the transfer function of the system here. The transfer function I will take, transfer function is nothing but Laplace transformation of output divided by Laplace transformation of input here. So Laplace transformation of output means L of, I will split this into 1 minus e power minus t, again minus t into e power minus t divided by Laplace transformation of step. Okay, so doing the Laplace transformation here, what you will get is 1 minus 1 by s plus 1 minus 1 by s plus 1 square divided by 1 by s. Now once we simplify this, we will get as s power 4 plus 2s cube, okay, minus s divided by s plus, let me correct here, s plus 1 whole cube here. See, all the poles, that is all the poles s plus 1 whole cube means the poles are lying on s is equal to minus 1 comma minus 1 comma minus 1. So all the poles are on the left half of the s plane. If you draw the left of the s plane, here we have minus 1 minus 1 minus 1 and 3 poles are there, so that we can say the system is in stable system. Okay, next we'll move to the two questions of this session here, the control system subject. Okay, right here the transfer function of a compensator is given by, okay, gc of s is equal to st plus 1 divided by s beta t plus 1 kc into beta. Okay, kc, beta represents the lag compensator. If for a lag compensator, remember this point, lag compensator, the pole must be nearer to the origin and 0 is away from the origin. So based on this concept, how many poles and zeros are here? The pole will be minus 1 by beta t, and here it is minus 1 by t here. So this is a pole and zero configuration of a lag compensator. For this condition to be satisfied, the t should be greater than 0 and the beta should be greater than 1. Okay, this is the concept here. Okay, answer will be 1 for this question. If you want, you can substitute any value here. Suppose t is equal to be 1 and beta equal to 2, you can also justify it. Suppose if you take beta is equal to 2 value, t is equal to 1, see 1 by 2 means 0.5. Okay, and here it is 1. So this is going to be progressing manner like this. So answer will be t greater than 0, beta greater than 1. Answer. Next one. A control system is defined by the following mathematical relationship. Okay, the response of the system as a t tends to infinity. So t tends to infinity means what they are asking is, they are asking the final value theorem. So final value theorem, what it says, limit s tends to 0, final value theorem, s into g of s you want. Okay, so we'll take the equation here on the right side of the equation is a time domain, left will be in time domain. So we'll convert this entire equation into s domain. So we know that d by dt square can be written as s to, okay, s square. So I'll write the equation as s square into x of s, okay, plus 6 into x of s plus 5, Okay, so 5 is equal to, so convert into Laplace transformation here, so 10 into 1 minus means we'll get it as 10 by s minus 10 by s plus 5, like this. Okay, once we simplify this, we'll get the answer as 50 divided by s into s plus 5. Now what is x of s? X of s will be equal to, okay, 50 divided by s into s plus 5 into s square plus 6s plus 5. So this will be the transfer function. Okay, now what we will do is we will apply limit for this transfer function. So this is limit s tends to 0 s into x of s. Okay, so what will happen is this x s will be gets cancelled. If you substituting s is 0, 50 divided by 5 into 0 plus 6 plus 5 means x of 5. So 50 divided by 25. So what the answer will get is, it is going to be 2. So x is going to be 2 here. Okay, so that's it for the session. Now we'll discuss in the upcoming session. Okay, so let me correct here one more point here. uh, in the previous question of right here, so Laplace transform output means here also I'll get 1 by s here. Sorry, let me make here 1 by s. Okay, so this statement is wrong here. So substitute this 1 by s here, 1 by s minus, if you're taking a Laplace transformation of 1 means 1 by s will get it. So from that we'll get the answer as a system is a stable system, right? Okay friends, thanks for watching my video. Have a nice day.